While we wait for people to file in, this webinar is being recorded. So after we are done, this is going to be safe and it will be sent to you at a later date. I'm going to say that if you have any connectivity issues, please log out and log back in, and that should take care of those things. And if you have any questions at any time, please put them in the chat, and I will read them to Dan after he's done with his presentation. So it's at 2:01. It is, once again, I'm going to introduce myself. My name is Sandy Delgado. I'm a forecaster here at the Tropical Analysis and Forecasting Branch, part of the National Hurricane Center. And today we have the pleasure of having Dan Brown. He's the specialist. Actually, he's the branch chief now of the Hurricane Specialist Unit. He used to be a specialist for a few years. I'm not going to say how many years. What that means is that he has a lot of experience, and he's going to share with us today. So, Dan, you're good to go.
Hey, thanks, Sandy, for the introduction. It's really great to be here with everyone today. Hopefully you find this is a learning opportunity to find out both a little bit about the forecast process and the products that are available to you to help you make those critical decisions when you are trying to traverse the ocean and staying safe from tropical storms and hurricanes. I know Sandy mentioned if you have any questions, so please put them in the chat. So please. The Hurricane Center talked about this a minute ago, really looking at the big picture products. It's our local offices, both within the National Weather Service and also the meteorological communities within the various countries that are providing that more local impact information. Looking, at the forecast cycle that the Hurricane Center works through. So we do this 4 times per day, issuing the advisories at 11 a.m., 5 p.m., 11 p.m., and 5 a.m. Eastern time. Each one of those cycles takes about 3 hours for us to complete. We start with an analysis, then actually make the forecast, coordinate those warnings and potential impacts. And there is time between those advisory cycles in which we are sometimes monitoring data that's still coming in from aircraft, looking at the new models in preparation for the next forecast, as well as provide information for media emergency management briefings, social media posts. There is really a continuous flow of information as the storms especially get closer to land. So looking at kind of how that analysis starts, I really want to talk about this for a few minutes. It's really, starting that process, we want to know where the storm is located, determining its latitude, longitude, what is that initial motion? We're using various tools to do that, and we'll talk about those here in just a second. The second question is, how strong is the storm? What are the maximum winds of the tropical storm or hurricane? And then lastly, it's really important, I know, for the mariners, how big is that storm? How far out do this tropical storm, 50 knot and hurricane force winds extend? And again, a lot of the ship and buoy aircraft scatterama data are very helpful to help us to determine some of these. So this is the data that we're typically using to, again, help with that analysis of the tropical cyclone. Really, one of the big bread and butter for us is geostationary satellites. We're able to look at the location intensity of these systems, estimate intensity from a technique called the Dvorak technique. Again, being able to animate that imagery helps us to determine where that center location is. We also use a lot of low Earth orbiting satellites to help look at storm structure. You can see some examples of that here on the upper right-hand corner. Again, it's low Earth orbiting satellite that our scatterometer data is on that helps us look to see what the wind direction and wind speeds are over the open ocean. And that can be very vital in determining whether or not the system has a closed circulation. Again, sometimes we'll look at that wind field of the system and also help with storm structure. Reconnaissance aircraft, that is vitally important information. So when a system is threatening land, we often fly reconnaissance aircraft data. they not only help with where the storm is located, but also really help again with what the structure of the storm is, help with intensity, and then lastly, they help with the size, understanding how big, how large the wind radii are in the storm. And then again, the ship buoy, land-based sites, surface observations are also very helpful. Of course, we want the ships to be out away from the storm, but it is often these buoys. There's even now sail drones that are providing some information as far as surface winds, sea heights. Those are also very helpful. And then as storms get really close to land, look at things such as radar imagery that can be really helpful for a system that is making landfall. One thing I would talk to here a little bit more about is how do we estimate storm size or wind radii? We do that via 4 quadrants. Again, there's often not a lot of data to help determine how far out these winds extend. Again, often looking at scatterometer data, ship buoy information to help determine this. And if you're familiar with some of our products, we'll talk about them a little bit later, but you'll see that the radii are listed in our products, like you see on the bottom left, in nautical miles, and those are the maximum extent of winds in that quadrant. Doesn't mean those winds are blowing everywhere in that quadrant, but those are the maximum extent of those winds in each of those 4 quadrants. And then we'll just say that starting this year, up to this year, we've been providing wind radii out to 72 hours, but this hurricane season, we've extended it out now to days 4 and 5. So you will get now at least tropical storm and 50-knot wind radii out to days 4 and 5. And you can see here on this table that the hurricane force wind radii are given out to 48 hours. So that's the wind field forecasts that are provided here from the Hurricane Center. Couple things I would like to tell you about here too is that there is analysis uncertainty. Again, given the lack of data, there is uncertainty in the analysis itself. So what do we think that uncertainty is? For location of tropical storms, we think it's typically within about 25 to about 45 nautical miles of where that center of that storm is located. Again, when storms aren't as well defined or in their formative stage, there can be sort of multiple centers. There can be reformation that occurs. So again, there's a lot more uncertainty, especially for weaker tropical storms. And that's why you see that the uncertainty is typically about 25 to 45 nautical miles. For hurricanes, you typically get a little more confident in that initial location, initial position, and that uncertainty is around 15 to maybe 40 nautical miles. Again, if it's a hurricane that has a well-defined eye, it's strong like a major hurricane, that uncertainty really drops down to about 5 to maybe 20 nautical miles. But again, when you see those advisory packages that have an initial position, there is some uncertainty in that, and it's actually indicated in that forecast advisory. Intensity, we say we're good to within about 10%, especially when we have recon data. For hurricane, we say hurricane's 110 knots. That's about what the range of uncertainty is, again, for that initial intensity estimate. And then we look at the size or wind radii estimates. The tropical storm force wind radii, we think we're good to within about 25%, and the hurricane force radii good to within about 40%. So again, if we're saying that one quadrant has tropical storm force winds extending out to about 100 nautical miles, given that uncertainty, really could be 75 nautical miles or even out to 125 nautical miles. Again, that's the uncertainty, just in the analysis, not really the forecast. So when we're talking about track and intensity forecasting, track forecasting is relatively simple. This is one of the reasons why we've seen such an improvement in track forecast. Again, as The global models have gotten better. They're forecasting these large-scale features that are steering a hurricane. So the analogy is really like the hurricane is a cork in a stream, and the atmosphere is a stream, and the hurricane is just kind of flowing along in the atmosphere. And again, because the features that are typically controlling tropical storms and hurricanes are often well-defined at large scale, does make forecasting track often a bit less complex and a bit maybe easier. Intensity forecasting certainly more complex. Again, there's interaction between thunderstorms and the core, the environment, the ocean. It's a lot more really what we call mesoscale, smaller scale features that regulate intensity, and so it just becomes a much more difficult issue to forecast. There's also things such as eye wall replacement cycles that we can monitor those, but again, very difficult to forecast. And those eye wall changes often result in changes in structure that can also cause fluctuations and changes in intensity. When we talk about wind radii forecasting, I've already talked about the radii themselves, but with the forecasting here, there's often not really, as much guidance available. We have some of the global models, but a lot of times it really is more limited towards climatology and persistence. Some of the basic ideas, if the storm is strengthening, it's often going to be growing in size. Is the storm becoming extratropical? Is it moving into more northern latitudes where storms often expand in size? Will parts of the circulation be over land such that the radii decrease? And just in general, is the system maybe accelerating? The ones that accelerate to the north often become more asymmetric with larger radii to the right of the storm motion. So again, these are some of the basic ideas that we're thinking about in forecasting. I think the global models have gotten better at forecasting wind radii, but certainly more limited than forecasting for track. One thing that I kind of cover here that we've seen some really great improvements in forecasting track over the last many decades. If you look at this graph, you go all the way back to the 1960s, 70s, and 80s, and you look at what that average 3-day, 72-hour forecast was, the average error, and it was on the order of 350 to more than 400 nautical miles. Well, it was really in about the 1990s when we started using more of the computer modeling, dynamical models that forecast use physics to forecast the evolution of the atmosphere. And it was really about then that we started seeing a real significant drop in the average forecast errors and our ability, increasing our ability to forecast the track of these systems. And you can see even that has continued to where in the 2010s, there was still a significant reduction in track error, and that has continued into the 2010s and 2020s, although the rate of improvement has been slowing recently. But you can see that average track error at 3 days now is less than 100 nautical miles. It's down to about 80 nautical miles. And again, just a real significant reduction in track error. The track errors do get larger as you go out in time with more uncertainty. But again, the track errors have been greatly reduced. When we looked at intensity, we didn't see much change from the 1970s even into the 2000s. But more recently, within about the past decade, we're starting to see some progress in forecasting intensity, which is good. And some of that has been forecasting rapid strengthening. There has been some improvement in that in very recent years. When we look at what the average track errors are, these are the kind of 5-year averages. That's about the sample size we look at. Again, kind of look at what typical uncertainty is in a forecast. And so the average track errors from the NHC forecast increased by about 35 nautical miles per day. So at day one, that average, the most recent average is about 36 nautical miles. Then it gets up to about 61, 90. And by the time you get to day 5, the average track error is about 174 nautical miles. And again, it's really good as someone that is using our forecast to make sure you understand what these uncertainties are. And we'll talk a bit more about some of the products that can help account for some of this forecast uncertainty. One thing too to remember is that the average track error actually decreases as the initial intensity of the storms get stronger. At least it does that on average. So you can see this graph here. This is the 1 day at 24 hours, the 2-day forecast 48, all the way out to 120 hours a day 5 forecast. And you can see when systems are weak, this is for tropical depressions and tropical storms that have an intensity of less than 50 knots. You can see those average errors, what they are in green, and the average track error for the tropical depressions and low-end tropical storms for 5 days is over 200 nautical miles. But as the initial intensity of those systems get stronger, the track errors tend to get lower. So for major hurricanes, the track errors on average are less than 100 nautical miles. And again, it's because the systems are better defined. Typically, or the steering is more defined for stronger systems, and the models tend to do a better job. So that's also something to keep in mind. As forecast evolves, as you're monitoring the forecast, that again, if the system is weak, you probably need to be checking in on the most recent forecast quite often to see how that forecast evolves. One good thing to look at, I know a lot of folks, there's a lot of interest in looking at some of the individual models and various computer models that are available and are out there. But here at the Hurricane Center, you have a tremendous amount of experience with the forecasters in our Hurricane Specialist Unit. Really, probably close to 100 years of experience combined with all the forecasters. And we use a combination of models called consensus models. And when we do that, it really does help to improve our ability to make forecasts. And you can see here that the Hurricane Center forecast, when we look at some of the individual models, so here's the ECMWF, the European model, the UK Met model, and the GFS model. And these are for day 4 forecasts for a 3-year sample. But the Hurricane Center forecasts had lower error and were more consistent than any of those individual models. Again, showing the value of the human input and hoping to build more trust in the Hurricane Center forecast. And again, we really hope that you're using our forecasts rather than a single model. So we look at the intensity errors. These are, again, the 5-year averages for intensity. They really increased fairly quickly in the first couple of days. This is about 8 knots for day 1 is the average error. By day 2, it's 10 knots. And then by day 3, it's about 12 knots. And then it kind of levels off. Unlike track, the errors kind of keep increasing with time. For intensity, they kind of level off. Again, intensity forecasting, a little bit more of a bounded problem. You really can only be so far off on intensity, whereas track, you can be very far off. So the intensity forecasts tend to level off after about 3 days. And then just was going to point out here too, that really the 24 and 48 hour intensity forecasts are on average off by about 1 Saffir-Simpson scale category. So if you really want to plan some safety margin, if you're looking at what the intensity could be, it's always good to potentially plan, especially in the deep tropics and really some of the subtropics, is to plan for potentially 1 higher than what is indicated in the intensity forecast to give you a little bit of margin of safety. Here is a look at some of the progress we have made in forecasting rapid intensification. If you look on the left, this was about 3-year sample from 2015 to 17. I think the main thing here is to look at where this black line, solid black line, that would be forecasts that essentially don't have much error. And looking at all the forecasts to the left, these are forecasts that under forecast the storm's intensity, and you can see just how many forecasts there were when rapid strengthening was either observed or predicted, that we had this really significant low bias in those forecasts, meaning, again, we weren't forecasting enough strengthening. More recently, the last few years, you can see that this graphic is now a little bit more skewed toward kind of the midpoint, a little bit less biased. There's still some significant forecasts that are too low, but we are actually forecasting rapid strengthening to occur, and there are some forecasts now that do overpredict the intensity. So you can see that bias has been reduced, and you can see that forecast error has actually been reduced by about 8 knots during this period, during periods of rapid strengthening. One storm I will point out, though, that occurred late last year was Hurricane Otis in the Pacific Ocean, and that was a case that, again, was very difficult to predict rapid strengthening, just to show that that can still happen today. But the good news here is that we have been making some progress in forecasting rapid strengthening. So now I'll kind of shift gears over into some of the Hurricane Center products that can really help you out. One product that I really encourage everyone to really kind of look at almost daily during the hurricane season is the Tropical Weather Outlook. Tropical Weather Outlook is both a text and graphical product. It actually will discuss the potential for tropical cyclone formation over the next 7 days. That was expanded last hurricane season. It used to be a product that covered 5 days, but starting last year, it was expanded out to 7 days. And it really provides the chances of formation and probabilistic terms over the next 48 hours and the next 7 days. This product is issued each day at 2 a.m., 8 a.m., 2 p.m., and 8 p.m. during the hurricane season. And just to also remind you that special tropical weather outlooks can be issued at just about any time to provide information on a disturbance. And there are also, as I mentioned, graphical versions of these products. So this is the 2-day graphical tropical weather outlook. Again, it provides what the chance of the system forming within the first 48 hours is. These are color coded again by their development chance. So anything with a less than 40% chance is shown to have a low chance of formation. Systems with a 40 to 60% chance are shown to have a medium chance of development. And then systems in red are systems in a high category that have a greater than 60% chance of formation. On the 48-hour graphic, there is a satellite image that is also provided, and you can actually click on those disturbances and it'll zoom in a little bit to each of those. There also is a 7-day graphic. Again, this provides the risk of formation over the next 7 days. And on this graphic, you'll see X's denoting the current location of the disturbance if it exists. If it's a circle without an X, it means that the system has not even formed yet. These are also color coded the same way that the 2-day is, with a low, medium, and high chance of development. And the shading area represents that potential formation area over the next 7 days. One of the products I'm sure you're very familiar with that does attempt to convey some uncertainty is our cone graphic. And this graphic shows the probable track of the center. And I remind folks, just the center of the tropical cyclone. Again, this doesn't provide a lot of information about the extent of the wind field. You can put on the initial wind field on the graphic to show you kind of a size estimate at the initial time, but again, it doesn't account for any changes in storm size during the forecast period. The cone is actually formed by connecting circles at each of the forecast time, such that the historical track errors would be that 2/3 of the time the storm verifying position should fall within those circles. So about 1/3 of the time, that actually fall outside these circles and potentially even outside the cone. So I think that's something to remember with the cone. The storms typically stay within the cone about 2/3 of the time, and about 1/3 of the time they can even track outside the cone. But as you see that the cone is very narrow during that first couple of days. Again, winds, high seas, impacts often, almost always occur outside the cone. Again, kind of reiterating some of that, is it only displays information about the track uncertainty. There's really no information about specific impacts or hazards, no information about the storm size, especially in the forecast, and that the impacts can occur well outside of the cone. And as I mentioned before, that the center could move outside the cone about a third of the time. One of the products that I think is really informative that you can help understand forecast uncertainty is the forecaster discussion. So if you ever really want to get into the brain of a hurricane forecaster, this is the product to really read. It can be technical. Sometimes there can be some meteorological jargon in the product, but it does provide information about the certainty or uncertainty of the forecast. Oftentimes, we'll talk about the forecast reasoning, some of the relevant observations justifying its intensity. We'll talk about model guidance, perhaps even alternate scenarios, and try to mention forecast uncertainty. Again, these are issued with each of our advisory packages, and again, can really be, I think, helpful for you to understanding uncertainty. There are also key messages often added to this product. These key messages are added when the system is a threat to land. So you'll see these key messages, again, that often talk about various hazards, perhaps storm surge, wind, heavy rainfall. They will also sometimes talk about the certainty or uncertainty in the key message and what the confidence is. So again, this is intended to really highlight the storm threats. And at the bottom of the discussion, there is a table of track and intensity forecasts that can be also handy if you want a really quick snapshot of those, what is the forecast. One product that I think is very helpful too, that helps convey uncertainty and what your wind risk is our wind speed probability products. There is both text and graphical versions, but they're location-specific probabilities. I'll talk about these location-specific for land first, and then I can show the graphics that do provide the location-specific risk over water as well. But these are the probabilities, again, of tropical storm force, 34 knots, 50 knot winds, and hurricane force winds. The text product contains a fixed set of location. It provides kind of cumulative probabilities, what's the risk of wind over the entire 5-day forecast period, and then what we call onset probabilities. What is the risk of winds beginning between certain time periods? And then there also is the graphical products that provides that risk at each location over a larger domain. So here are a look at those graphical products. Again, they're providing location-specific chances of 34, 50, and 64 knot hurricane force winds over the next 5 days. The beauty of these products is it uses the past 5 years worth of NHC errors to understand what their typical track forecast or track intensity and size uncertainties are, and it accounts for those. So it runs 1,000 different scenarios. With each one of those has intensity and wind field associated with it. It's bounded around the official forecast to come up with the risk of wind. Here is an example of that. So again, we take the official forecast. Those are the symbols that were on this graphic, and then the historical track intensity errors are sampled. It creates 1,000 different alternate scenarios surrounding that official forecast. And you can see those here. They're color coded again by intensity, and then each one of those has a wind field, and then it does account for weakening when systems move over land. It does take into account the spread in the track models. So when the track models have a lot of spread, NHC errors are typically a little higher in those cases. So it will spread out those 1,000 realizations. When there's the track guidance is in better agreement, it actually can narrow those 1,000 realizations. And again, it is situationally using that uncertainty information to again create these probabilities. And in this case, if you show you how they're calculated, in the same case, here we circle New York City, and we look at those 1,000 realizations. 590 of those produce tropical storm force winds at New York City, which then equates to a 59% chance of getting tropical storm force winds at that location. And again, we can see the graphics in a second that'll show you that you can look at that for locations over water. One other graphic that uses the same methodology is this earliest reasonable time arrival or time arrival graphic. So we have an earliest reasonable and the most likely time arrival graphic. The earliest reasonable graphic, again, is kind of your most conservative timing. If you really want to make sure that you have exited an area before the winds could begin, or make sure all your preparations are complete before the winds begin, we would suggest that you use the earliest reasonable time arrival. If you have a little more risk tolerance, you can use the most likely time arrival. Again, that's when the winds are most likely to begin. Tropical storm force winds most likely to begin at a location. So you can see on this graphic here, again, the storm centered near eastern Cuba. This is showing those wind speed probabilities for tropical storm force, along with the earliest reasonable time that those winds could begin. So if we're looking up here near southeast Louisiana, those winds could begin as early as about Tuesday evening or Tuesday at 8 p.m. And then we can look at the most likely time arrival graphic, very similar graphic. You got to really look at the legend of the graphic to make sure you're looking at the correct one. But in this case, it's suggesting the winds are most likely to begin Wednesday morning in that same area. So you can see there's about a 12-hour range here indicated on when those winds could begin because of the uncertainty. But it's always good, I think, for planning to kind of look at, again, both the most likely time arrival as well as the earliest reasonable time arrival. And again, you can use this graphics if you're interested in locations over water. Again, both the probabilities are for locations over water as well as the time of arrival. One graphic, if you have a shore interest here, is the potential storm surge flooding map. This is a graphic that does provide your risk of storm surge. It is showing a reasonable worst case scenario. So it shows really inundation levels that have a 10% chance of being exceeded. Again, it's not a flooding footprint. Not every location on that map is going to get the flooding that is shown, but it provides you with what you should be planning for. What could happen when a storm is nearing the coast. Again, this is accounting for uncertainty, both in the track and intensity, landfall location, and in providing, again, that reasonable worst case scenario. Again, you can, on our website, you can zoom and pan on this graphic and again, look at the potential for storm surge inundation. The first map's issued whenever a storm surge or hurricane watch goes into effect. And it does take a little bit of time to process the data, so it's not available right at the top of the hour with all the other products. It's more like really within about an hour. I would say 90 minutes is perhaps a little too long, but usually within about an hour of the advisory going out, this potential storm surge flooding map does become available. And again, just a great tool to see what your risk of storm surge and how high that water could reach. But again, it's not showing the flooding that's going to occur everywhere, but just what that risk is at each location on the map. There is a newer graphic, the peak storm surge forecast graphic, also provides information about what the storm surge inundation could be. This really shows more of what the expected inundation is along the coast. showing what those maximum values could be along various segments of the coastline. This mirrors what goes into our public advisory at the Hurricane Center, the text product. We'll have these same areas denoted with those storm surge values. And again, it basically issued when watches and warnings go into effect, and again provides this look at that storm surge potential for those sections of coastline. Couple things, a reminder about tropical storm and hurricane watches and warnings. One, tropical storm watch that's issued when conditions are possible within the watch area within about 48 hours. And then the tropical storm warning is issued when conditions are expected. And I say somewhere, not everywhere, but somewhere within the warning area within about 36 hours. And then the hurricane watch is issued when conditions are possible, again, within the watch area within about 48 hours. When actually tropical storm conditions are possible within the watch area, generally within 40 hours. The lead time of these are tied to the arrival of tropical storm force winds. I want to remind folks of that. Again, we want, generally you want preparations to be complete before the hazardous weather begins. So the hurricane watch and warning are tied to the arrival of tropical storm force winds. So again, the watches that hurricane conditions are possible, the hurricane warning, hurricane conditions are expected, again, somewhere, not everywhere, somewhere within the warning area with those tropical storm force winds beginning within about 36 hours. Storm surge watch warning. This is really, it's a newer watch warning. It's been around for now more than 5 years, but somewhat newer. But it really is to ensure the proper response when there's life-threatening storm surge that's either possible or expected. So it is intended to, help with the public response and to help guide emergency manager decisions. It really does highlight areas that have a significant risk of life-threatening inundation from storm surge. So the watch is issued about 48 hours before the arrival of the storm surge or other hazards, such as the wind that could hinder evacuations. And then the warning is issued about 36 hours before. And again, these watches and warnings are collaborated between the NHC Hurricane Specialist Unit, our Storm Surge Unit at the Hurricane Center, as well as those local National Weather Service offices in the affected areas. Just to show you again, how we do account for uncertainty when we're issuing watches and warnings. Again, we want a little bit of a level of safety margin with these watches and warnings. Again, a hurricane force winds, extreme event. So we really want to try to make sure we capture the area that has the greatest risk for those winds or even storm surge. So really, for at least the hurricane warning, the size of the warning is really based on a few things. One, what is the forecast track? What is the storm size? How far out do those hurricane force winds extend? And then, as a forecaster, what is the assessment of that uncertainty in the forecast? So you can see here the exact forecast track is up toward the middle part of the coast of South Carolina, but knowing what the forecast uncertainty is, the storm can move a little to the right, could move a little to the left, could actually grow in size. It's not really shown here in this graphic. So based on that, we would recommend an area that's a little larger than that exact forecast track. Again, accounting for that uncertainty and making sure that folks that need to take preparations understand their risk and are able to do so. Orientation with the coast does play a major role. So a storm that's moving more perpendicular to the coast, perhaps a little bit smaller warning area versus something that's more paralleling the coast. Again, a storm that's coming, say, up the Florida Peninsula from the south all the way to the north would probably require a lot larger watch or warning area than a storm that was moving more east to west coming into the Florida Peninsula. Some of the watch warning considerations for us: one, we want to try to maintain continuity as best we can with our previous watch warning decisions. We certainly don't want to put somebody in a watch or warning and then take them out and have to put them back in. So we do want to make sure we're maintaining continuity. One thing we also can consider is, sometimes we see trends in the model guidance. And if we expect that the forecast may be shifting from, say, west to east, that might play a role in what we want to place under a watch or warning. Again, the forecasters here have a really good sense of that uncertainty in a given forecast, and can also, perhaps if it's a very uncertain forecast, may suggest that we issue a larger watch or warning area. It can also be affected by the vulnerability of the area affected. Several years ago, Hurricane Irma struck Barbuda, and that was shortly thereafter followed by Hurricane Jose. And in that situation, there was a need to put up a watch a little earlier, again, because the population was quite vulnerable after the hit of a major hurricane, again, to make sure that they were aware that there was a threat of another storm. Time of day or week can also play a role. Again, sometimes we want to try to get folks plenty of daylight hours to make preparations. Issuing warnings, say at 11 p.m. Eastern, it might be better to try to issue that at 5 p.m. Maybe one forecast cycle before, to again give people more information to make those preparedness decisions. Just looking at kind of some of our watch warning coordination. So we at the Hurricane Center, we are what's called a regional specialized meteorological center. We essentially recommend the placement of watches and warnings to I think it's 28 member nations across the Caribbean, Central America, Mexico, Canada, Bermuda, other areas, islands out in the Atlantic. But it is up to each country to actually issue their watches and warnings for their respective areas. So we talk to the meteorological services of those countries, coordinate with them, and then be able to display those watches and warnings on our products, indicate when those watches and warnings are issued. This is often coordinated with phone, email. Sometimes now we do video teleconference calls with the affected region, again, to coordinate these watches and warnings throughout the Caribbean, Central America. This slide I threw in here to remind folks of kind of what type of systems do we issue advisories on at the National Hurricane Center. So we issue advisories, of course, on tropical cyclones, which include tropical depressions, tropical storms, and hurricanes. But we also can issue advisories on post-tropical cyclones. These are systems that remain a threat to land, like Sandy was back in 2012. It became what we call post-tropical, meaning it lost its tropical characteristics, but it still was a threat to land. So we continued with some of our hurricane and tropical storm watches and warnings, and the Hurricane Center continued advisories on those systems. If a similar system like that is not a threat to land, then that's when the forecasts then become the responsibility of either the Tropical Analysis and Forecast branch here at the Hurricane Center or the Ocean Prediction Center to issue those marine watches and warnings. Potential tropical cyclones is a system that's not yet, hasn't quite developed into that tropical depression or storm, but it does have the threat to bring those tropical storm force winds to land. And when we're forecasting those systems to become a tropical storm or hurricane and affect land within 48 hours, we have now the ability to issue these potential tropical cyclone advisories to highlight that wind risk for land. Similar systems of the open ocean and not expected to impact land within 48 hours. Again, information about those systems would be found in those marine forecasts, again, issued by both the Tropical Analysis and Forecast branch of the Hurricane Center, as well as the Ocean Prediction Center. Just to look kind of a timeline of when things are available. We've already talked a little bit about this, but when there's no watches or warnings for land areas in effect, we issue a public advisory, a forecast advisory. You see those wind speed probabilities in that forecast cone at 5 a.m. each day, as well as 11 a.m., 5 p.m., and then 11 p.m., and then it repeats into the following day. Whenever there are watches and warnings in effect for land, we issue what's called an intermediate public advisory. Again, this is not a new forecast track, but provides updated information about the storm location, about the intensity, perhaps about the size, and any updates to any of the hazard information. And those would be issued at 8 a.m., 2 p.m., 8 p.m., and 2 a.m. each day. And then when systems are nearing landfall, if they're easily tracked by National Weather Service radar here in the United States, we can issue what's called a tropical cyclone update, providing hourly information, again, to the initial location and intensity of the system. And in those, we'll often talk about some of the observations that are being reported along the coast or just offshore. Special advisories, I like to remind folks about special advisories. These can be issued really just about any time. They're issued, when an unexpected change has occurred, perhaps the storm is strengthening more quickly than was forecast, or even if the track has shifted, we can issue these special advisories to update the forecast. This is done a few times each year. Again, probably most often when the storms are strengthening more than what was indicated in the previous forecast. We can also use these to issue, U.S. watches and warnings between regular advisories. Although starting this year, we do have the ability to now issue watches and warnings on intermediate advisories in the U.S., but we can still also issue special advisories if we really want that information to get a bit more, be a bit more highlighted. So a couple things to look ahead, and before I wrap up here, one, I'll just mention that in-house we are working on 6 and 7 day track forecast. This is potentially something that we'll be issuing in a few years, maybe 2 to 3 years. We'll working on this internally. We've been making them these forecasts now for since 2016, except for a 1-year hiatus there. And the 6 and 7 day forecasts on average are about as good as the 4 and 5 day forecast when they were introduced back in 2001. Again, we have some tentative plans to maybe make these forecasts public within a couple of years. How we do that is still yet to be determined. We're discussing that. I will say that last year, we had some long-lived weaker systems that I mentioned early on in the presentation. These weaker systems can be more challenging to forecast. Well, that was true last year. And so you can see the average errors last year were up a little bit. But in general, the 6 and 7 day forecasts, again, have been about as accurate as those 4 and 5 day were. We started issuing those a little more than 20 years ago. So again, something that we are continuing to look at and see how best it will be to communicate those. This is one here, though, that a case, this was from Florence back in 2018, where it's still somewhat problematic. And, again, there can be great uncertainty at the longer ranges. This was a forecast that, again, we were making these in-house at the time. This one showed Florence kind of moving more northward, starting to recurve east to Bermuda. Whereas what really happened was the storm moved kind of northwestward and then slowed down, turning more to the west. And you can see that forecast was off by nearly 700 nautical miles. And eventually the storm became, a threat in the U.S., made landfall in the U.S. So again, this is why we've been careful about moving forward with 6 and 7 day forecasts. But again, I think we're getting closer to issuing these publicly within the next few years. The last thing I'll end with here, the last slide, just a reminder, and this may be talked about in the other webinar, is that there is a mariner's guide that provides more information about all these products that was updated about a year ago by a former forecaster in the Tropical Analysis and Forecasts branch, Dylan Flynn. And again, it provides kind of the latest information about the National Weather Service and Hurricane Center Tropical Cyclone Forecast. There's some sections on climatology basics. So just a really great guide that you can download from the website, again, to get all this information you need. Really a great guide to have around on the bridge of a ship, just to good reminders of knowing what products are available and even perhaps when to use those. So I think that's all I have, Sandy. Hopefully, I'm sorry for the technical difficulties at the very beginning, but hopefully the remainder of the webinar went well and you found it useful.
Excellent, Dan. Yes, I have few questions here that we have gotten so far. So, so I have a question here about if you're going to talk a little bit about the new cell drones or other drones that are being deployed for data collection and how is this anticipated to improve models and forecasts?
Yeah, so we've started to look at the cell drones. It's they have provided us with some wind and sea information at times. Some of that information is getting into some of the model guidance. Again, it's one point out in the ocean at the moment. Again, those observations, less like buoys, can be useful in data assimilation. And we are starting to look at those here at the Hurricane Center.
Okay. Another question that I have here for you is when you talk about here we talk about European models, what is that sometimes reference about? And that question came when you were talking about the models that you use to indicate the wind percentage or the probability of tropical storm force winds.
Yeah, there's several forecasting centers around the globe that are on a regular basis, basically every 6 or 12 hours, running these what we call global forecast models. And the European Center is one that is doing that. Their model is one of the best. So here at the Hurricane Center, we're looking essentially at that European model. The GFS is kind of the American version of a global model. There's a Canadians run a model, Canadian model, the United Kingdom. So there are these various global models that we look at when forecasting. There are also more sophisticated, what's called regional hurricane models that have higher resolution, actually can assimilate some of the aircraft data. And we are also looking at those models. But the one point of that slide I showed was that as forecasters, we are really consolidating all of that information, looking at even some of these consensus models. Some of those models, the global models, are run 25 to 50 times in what we get called ensembles that also provide valuable information. So again, we're looking at all this data, using that experience to make that forecast. And we really want you to be using our forecast. Don't really try to make those decisions on the track of using those models yourselves. Leave that up to the professionals and the amount of experience we have at the Hurricane Center.
Okay. Another question that I have here says, what conditions warrant a threat to land? And I think that was came in when you were talking about tropical storm watches and warnings and hurricanes. So.
Yeah, it's it may be too related about when we fly aircraft. So if a system is has a land threat potential within the next really several days, is when we'll start flying those aircraft. For watches and warnings, it's really within about 48 hours is when we issue those watches and warnings. But for the reconnaissance aircraft that we often fly, it's really any system that has a threat, even if that threat is 3, 4, even 5 days away. We will likely begin to fly that again to collect additional data about the system. Can help with the track forecast. And again, we're trying to provide use that data to provide as good a forecast as we can make, even at the longer ranges, if we think a system might threaten land down the road.
Excellent. Dan, can you talk a little bit about the predicted number of storms this year and what causes, led to that forecast and etc.?
Yeah, the NOAA seasonal forecast is pretty confident that it's going to be a busy hurricane season. Forecast indicated about an 85% confidence of an above normal hurricane season. The forecast was for 17 to 25 named storms and 8 to 13 hurricanes. It is the highest seasonal forecast that NOAA has issued. A couple factors have led into that. One primarily being that we had El Nino conditions out in the Eastern Pacific. Those have been transitioning what we expect to La Nina conditions before the peak of the hurricane season. We have La Nina cooler waters in the Pacific. Tends to allow more favorable conditions, less wind shear across the Atlantic, allowing these storms to form and strengthen. as well as across the Atlantic Basin, just very warm sea surface temperatures at the moment. Some of those sea surface temperatures are about as warm as what we would typically see in August. We're already seeing that in early June. So again, the combination of the warm waters and what is expected to be more favorable upper level environment across the Atlantic has led to, again, the forecast for a quite active hurricane season. I will mention, though, it doesn't tell you where the storms are going to form, where they're going to go. You know, it only really takes one to affect your route, wherever your interests are, for it to be a bad hurricane season. So again, you got to, the key message there is just really pay attention and be prepared this hurricane season.
Excellent. Another question here that is related to what you just said is it the National Hurricane Center that assesses the likely number and intensity of future hurricanes in a season?
So, I mean, the seasonal forecast is looking at more of sort of the bulk numbers, the number of named storms that form, number of hurricanes, number of major hurricanes. That forecast is issued by the Climate Prediction Center, part of NOAA. We have a few folks here from the Hurricane Center that are on that team that does produce the seasonal forecast. But that is a product that is issued by the Climate Prediction Center, and that seasonal forecast will be updated usually updated in early August, looking at, again, before the peak of the hurricane season.
Excellent. Another question that I have says, are there any common factors why Cindy, Irma, and Ian were forecast to track to the west coast but turn inland around Charlotte Harbor?
That one I don't know that I can answer right off the top of my head. It's more specific. I will know that, last year I think Philippe was one storm that was very challenging to forecast. Again, it was weaker. Some of the models were suggesting Philippe would get stronger and turn more to the north. Again, the depth in the atmosphere the storms attain can play a role in what the steering currents are going to be. So in the case of Philippe, the storm did not strengthen as forecast, stayed weaker, and was steered more by the low-level flow, which allowed it to go more westward toward the islands, affecting the islands. And that was one storm that really contributed to the higher than average track errors for the entire season, because again, it was so difficult to forecast not only its intensity, but also track.
Yeah, definitely. I also think that the coast of Southwest Florida, the way that it is, the topography, the geography, basically makes it that any system that is moving in that direction, northern direction, just a slight change to the right can make a significant.
Absolutely. When you look at Charlie and an Ian on the west coast of Florida, that angle of approach being really so small, just a small shift left or right of track made a huge difference on where those storms made landfall. Again, you get something that's nearly parallel. That west coast of Florida turns a little to the right early, can make landfall in Naples, Everglades City, Southwest Florida. Again, just a little left of that, it could stay further north, making it all the way up into the Florida Big Bend. So again, storms like that, it can be very difficult to pinpoint both the timing and location of landfall. And again, that's why we really want folks to be looking at some of these products that provide more uncertainty information.
And one final question, just before we let you go. Does the National Hurricane Center work directly or indirectly with weather routing outfits for more accurate routing?
So not to my knowledge, no, that we really don't work with the routing folks. Again, products issued by the NHC hurricane specialists. We issue products that, again, the mariners can absolutely use, but also that information is used by both the Tropical Analysis and Forecast Branch and the Weather Prediction Center to then produce their marine forecasts, again, trying to provide really a consistent message about the storm's path, size, hazards, wind and seas associated with it. Again, it's a consistent message that you'll get from the Hurricane Center and the Ocean Prediction Center and Tropical Analysis and Forecast Branch.
Thank you, Dan. And this question leads me to the next thing, which is like tomorrow. This will be a very good question to ask Dr. Chris Lancy from the branch chief of the Tropical Analysis and Forecast branch, which is the marine portion of here at the National Hurricane Center. And thank you so much, Dan, and thank you everyone for being here. Sorry for the technical difficulties, and have a safe hurricane season, please. Take care.